Welcome back, Math 098. We're going to continue on with Chapter 5, Section 2. And I know this always cuts off on me, function, scientific notation. Now, there is a rule, but it makes sense for students to just rewrite these power notations, because to the fifth power means you take what's inside the parentheses and do it that many times. So there are 5 of these z to the thirds. And then you can use the rules we learned in section 1. Well, if we're multiplying with the same base, we can just add the exponents. Or you could rewrite it all out just like we did in section 1. Z, 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 Z. Anyway, there's 5 of these 3's. So 5 times 3, kind of giving away my next question, that there's 15 of these z's total. And I said times, I'm trying to clue you in that when you take a power to a power, you multiply those exponents. So there's kind of your rule. Power to a power is your clue to multiply. So again, I'm okay if you write the final answer, but I'm really looking for what do you understand that 5 to the second is the same thing as 5 to the fourth, because 2 times 2 is 4. Maybe I should have came up with a different example, because 2 plus 2 is also 4. I don't want to confuse you. It's by multiplication. Now, this is the answer I want. If anybody goes ahead and rewrites that 525, 125, 625, you'll get full credit, but a calculator could have told you that, and that's not what I'm trying to get you to understand. Same thing with the next one is, remember, we can only use positive exponents. So if you rewrite this as 3 to the negative third, that's not good enough, because it's not simplified until you only have positive exponents. And as a reminder, a negative exponent gets put into the denominator. And if anybody's sitting there and saying, oh, well, I know 3 cubed is 27, 3 times 3 is 9, times 3 is 27, yes, you'll get full credit. But that's not the point of this lesson. And then negative times a negative is positive. 4 times 6 is 24. That is it on that. And then we're just going to add in new rules, like make sure that you do each piece. And maybe I'll write this first one out at least a couple times, because remember, you take everything that's in the parentheses and multiply by itself. So it's very important that you take each piece to the fifth power. Now, I'm okay if you just leave the answer like this, because I've been telling you to do that so far. 3 times 5 is 15. This is acceptable, or if you actually figure out 2, 4, 8, 16, 32, I'll accept both of these answers. Now, what I will not accept, let me write this in red like it's bad, is some students, they get confused because power to a power you multiply, so that's correct. But then they try to write it as 10 x to the 15th, which is definitely wrong, because 2 to the 5th is not the same thing as 2 times 5. So just giving you that heads up. And I did not give myself much room here, but again, you just square each piece. So I'm fine if you leave it as 3 squared over 5 squared. And because I didn't have much room, I'm just going to put a box around that. Otherwise, you can write 9 over 25. All right, let me change colors. This one, just make sure you do each piece. Again, you can leave it as 2 to the 4th, a to the 20th, because 5 times 4 is 20, over b to the 28th. All right, that works. Otherwise, you can rewrite 2 to the 4th, 2, 4, 8, 16. 16, a to the 20th, over b to the 28th. Letter D here, I would just rewrite this as 3 squared over x to the negative first, but this is not acceptable. We have a negative exponent. So how do we fix negative exponents? Goes into the numerator. And again, you can leave it as 3 squared x, or you can rewrite it as 9x, because 3 squared is 9. And then this last one, before simplifying any negative exponents, I would go ahead, and I'm hesitating to use the word distribute, but every year I do use it because it helps some students, is when you have several different bases taken to a power, you just distribute that base in there. And remember, you still multiply. So -2 times -2 is +4. -5 times -2 is +10. And 4 times -2 is -8. And this is not an acceptable answer because you have a negative exponent. Well, what do we do with negative exponents? We stick into the denominator. Stick it on bottom, make it positive. There's the answer we need. We can just keep going. I know other teachers may teach this slightly different, so you don't have to do it my way. But my way does work. If you were to distribute that -3 to each one of those powers, negative times negative is positive, 5 times 3 is 15. But then the answer we need to have written is b to the 15th stays in the numerator because it's positive, but then you have to stick the a in the denominator. And I'll leave it up to you to rewrite this as 3 to the positive third in the denominator, or 27. 3 times 3 times 3 is 27. Now some students will actually simplify this first because it's bigger on bottom. So we're looking at subtracting, because we have the same base. -4 minus -7 makes it +3. But then with that negative exponent, well, 1 to any power is just 1. I hope you know that. 1 times 1 times 1 times 1 times 1. However many times you want will give you 1. And then you have y to the -15th, in the denominator. Let me scroll down a little bit so you can see. So how do we fix a negative in the denominator? You move it into the numerator. And you may work through this slightly different, but you should end up with y to the +15th power there. Let me change colors. I'm tired of these colors. I've also seen students do the problem this way, where if you have a negative exponent, then do the reciprocal of each one. And then when you do the reciprocal, it's now a positive exponent. I hope you realize that's correct as well. Otherwise, you can play around with this problem and see what you get. And I'm going to leave it up to you if you want to leave it as 8 squared over 3 squared. Or you can rewrite that as 64/9. One of those two answers is fine. I'm going to put a box around this one because I like this one just a little bit better. And this problem, my fraction went away. That happens every time I scroll down, the fractions go away. But yeah, just remember that what you're going to get is that 9 to the -2nd power goes into the denominator. So it's 9 to the +2nd power. It's larger, a is larger. So subtract 2 minus -4 becomes a to the 6. And the b is larger on top. So then 3 minus -5 gives me 8. And I'm happy with that answer, so I'm going to move on. Feel free to pause, by the way, and see if you get a slightly different answer if you want to work it out at all. Again, I would encourage students to simplify anytime you could. For instance, I'm looking at these a's. You can simplify, it's larger on top. So I would rewrite this as 5a to the 12th b over c. Remember, 4 minus -8 comes 4 plus 8. And then if I'm heeding my own advice on how I did an earlier problem, I would flip it. To make it a positive exponent on the outside. You don't have to do it that way because you can distribute it all in and then you'd have a bunch of negatives to then flip. Otherwise, my answer, I don't have to flip anything. I just have to distribute that 3 in there. And you don't even have to figure out what 5 cubed is. It's 125 though. And multiply 12 times 3 is 36. There you go. It's a good answer. Again, all of these kind of got ruined for me. So maybe I'll show you that method. Is distribute that 3 in. So you got 2 cubed, x to the 12th. Maybe we can do two steps at once. I can move that y to the numerator, so it's now to the positive second power, times that 3, make it 6, over 5 cubed, and then times, well, if we distribute this -1 in here, it's just going to become x to the positive fourth, distribute that y to the positive second. Now 10 to the negative first, I can just stick into the numerator. And then from here, I'm just going to leave it up to you how much you want to simplify, because you could divide both of these pieces by 5. Let me go ahead and do that for you. If I divide this by 5, so reduce that by 5, now I get another 2 in the numerator. 2 to the fourth, it's going to become x to the 16th because you add your exponents. And then it's going to become y to the fourth in the numerator because 2 of these will cancel out. So 6 minus 2 is how I did that. I'm also going to divide this by 5 because if I divide the numerator by 5, I need to divide the denominator by 5. So now it's just 5 squared in the denominator because I got rid of one of those 5s. All right, feel free to come to class with questions on this. Okay, just because I showed you one way does not mean I expect you to understand everything perfectly. So, and feel free to pause as well if I'm going too fast. So the way I would do this next problem is not worry about the negative yet. So as I'm looking at this, I need to distribute that 3 in. So 3 to the third power, and then x to the 3a. Because this is all multiplication. I had the same base, so I can add my exponents. It's up to you. Sometimes I'm doing 3 times 3 times 3, and sometimes I'm not. But now you can just add your exponents, -2a plus 3a. So the answer I'm just looking for, and again, you can leave 27 as 3 to the third power, and -2a plus 3a, since they're like terms, is 1a. So there's that answer. And the same thing goes with the next one. This is the same thing as a y to the 9b over y to the 4b minus 3. Well, remember in the earlier unit, when you're dividing, you just subtract the quantity. So we're left with y to the 9b minus 4b is 5b. And don't forget that subtracting a negative turns it into plus 3. So y to the 5b plus 3 there. And then we're going to throw in some scientific notation at you as well. So the main thing here is when you're multiplying 3.4 times 5, let's see, well, let me just get that down. 3 times 5 is 15, but 0.4 times 5 is 2.0, so it's really 17.0 times 10. Remember, you add your exponents here. When you're multiplying, you add your exponents, so 4 plus -3, or sorry, 4 plus -7 is -3. But it might actually be to your benefit to write that out. What does that actually mean is moving that decimal back. So 17, move that decimal 1, 2, 3 times. So it's 0.017. And the reason why I'm doing that is we want to write it in scientific notation. So let's move the decimal back 2 times, and we're looking at 1.7. Since I only moved it back twice, it's 10 to the -2nd power. And the reason why you have to do that is, remember, this number right here must be bigger than 1 but smaller than 10. 17 is not smaller than 10. All right. All right, I need to hurry to finish this. When I divide these two, you get 0.4. And when you subtract here, you get +10. But remember, in scientific notation, you have to move it this way. So it has to be bigger than 1. And I skipped ahead and wrote down the answers to these last two because I don't want a new video. And here's your homework. Notice the multiples of 4 and all of these.